Hello, my name is Angad Kahlon, and I'm in Com 380 Artificial Intelligence at UFE for the semester fall 2023. This is my presentation for Lab 8 Probability and Belief Networks. So, part one of this lab is the preliminary questions. So, question A is explain what it means when two variables are independent, also called marginal independence. So, if two variables, for example, A and B, are independent or marginally independent, that means the knowledge of one variable does not affect or change our belief or knowledge of the other variable. So, in terms of probability notation, that means that the probability of A and B is equal to the probability of A times the probability of B. So basically, the two variables are not connected or influenced by each other. Question B is explain what it means when two variables are conditionally independent. So if two variables, for example A and B, are conditionally independent, that means that the knowledge of one variable does not change our belief or change our knowledge of the other variable given some information of a third variable C. So in terms of probability notation, if we have the probability of A and B given C is equal to the probability of A given C times the probability of B given C. Question C is what is the independence assumption in belief networks? The independence assumption in belief networks is that each random variable is conditionally independent of its non-descendants given its parents. Meaning, given information about the parents, we can conclude that each random variable is conditionally independent of everything that is not its descendant. So, the source I've used for some of these questions is this website. Part two of this lab is the belief net. So we're supposed to run the belief net tool from AI Space and open the fire alarm example problem. So in the solve tab, without making any observations, if we make a query on the variable smoke, so query on the variable smoke, we can see that the probability for being true is 1.89% or 0.0189. For question E, once we observe that fire is true, what is the probability of smoke? So we can do fire is true. So query on smoke, it's showing that the probability is 0.9 now. Question F is observe that fire and alarm are both true. Now what is the probability of smoke? So fire is already true. We can make alarm observe true. And then we do a query on smoke. It's showing 0.9 or 90%. So are the answers to E and F the same? So the answers to E and F are the same as the value of alarm does not affect the value of smoke. Only fire affects the values of alarm and smoke, meaning alarm and smoke are conditionally independent, as we can also apply the independence assumption that states that random variables are conditionally independent of its non-descendants. Alarm and smoke are not descendants of each other, given information about the parent fire. So we have information about the parent fire. We can conclude that the alarm and smoke are conditionally independent from each other. So they're going to be, the answer is going to be same because alarm does not affect smoke, only fire affects smoke. So part three of this lab is the conditional independence part. So we are supposed to go in the solve tab, click the independence quiz and answer these questions. Is leaving independent of fire given alarm? So independence quiz, we can ask a question, is leaving actually, I'm just going to quickly make this not true, none. So independence quiz, we ask the question, is leaving independent of fire given alarm? So get answer, and the answer is true. Is leaving independent of report given alarm? So we can do ask a question, is leaving independent of report given alarm? Get answer, and the answer is false. And the answer is true for this one because leaving is independent of fire given alarm, which makes sense as it is not, if we look in real life, it's not certain that someone will leave if they do not hear an alarm, but there is a fire. And for this one, this makes sense in terms of the independence assumption as well, as report is the descendant of leaving and leaving is the descendant of alarm. With regard to real life scenarios, writing a report is not independent but dependent on leaving, and leaving is dependent on the alarm. So you have to leave to write a report, and leaving is depending on the alarm. Thank you so much for watching and listening.